once an equation has a trig function in it, you're going to have lots of solutions. You're going to have many. It's possible. I mean, it doesn't always happen, but it's possible that there are many solutions. If you've got a polynomial function that's linear, there's only going to be one solution. If you've got a quadratic equation, there's either 0, 1 or 2. Right? There aren't many, but not the case when you've got trig functions because the graphs keep repeating. And so to get an idea, I said using graphs can help us see this. So to begin with, here's just an example where we're working graphically. So it says, how many solutions are there in this interval between 0 and pi for the equation sine 2x is equal to cos x? And so what you would do is you would graph y is equal to sine 2x, and then you would graph y is equal to cos x and see where those graphs intersect, and that will tell you where those values are equal. And so sitting in here, if you were to go through what we just did and graph sine 2x, the graph of sine 2x is the graph of sine x compressed by a factor of 2. The period will be pi, 2 pi on 2. So there is, and I've only just gone between 0 and pi because that's what it asks up here. It says I'm only interested in that little interval for the moment. So I've only gone up to pi there. So there's the graph of y is equal to sine 2x between 0 and pi. I would then draw the graph of cos x. Here it comes here. Comes down nicely like this, down to there. So that's the graph of y is equal to cos x. And we can see as we look at those graphs that they intersect here, here, and here. And so I'm going to have three solutions. I'm going to have x1, x1, x2, and I can see that x2 I think is pi on 2, and x3. So I can see there will be three solutions between 0 and pi for that particular equation. So I can say on x between 0 and pi, there will be three solutions. And let me just for the minute call them x1, x2 and x3. Now from my picture I can see that x1 is somewhere between 0 and pi on 2. So in terms of our quadrants, I would say that's a first quadrant answer. Does that make sense? On, I can say here, 0 is less than x1 is less than pi on 2. And remember in here, we're thinking of these, or we can think of the x here as representing an angle in radians. And pi on 2 is the same as 90 degrees, if you like, in degrees. And so if I had my quadrant, there's, if I use theta rather than x, actually no, let me, I will use theta. Theta equal to naught is there. Theta equal to 90 degrees is up here. So that's theta equal to pi on 2 up there. And so anywhere between 0 and pi on 2 is an angle that's that puts our point in the first quadrant. So we would say, i.e. a first quadrant solution. There's an angle in the first quadrant that makes that equation true. You can't even see my nice little picture up there. Theta equal to 0, theta equal to pi on 2. So somewhere I'm in this first quadrant. As I said, I could have used thetas in here, but once we converted to radians, the convention is that we call the angles x. And so in this picture up here, I would do better to call the coordinates x dash and y dash to say that it's not that x, this is a different x. So having x's is good when you're talking about functions. Having x's is not good when you're talking about degrees. But unfortunately, you know, you've got to choose. Anyway, the second one, the second solution we think is pi on 2. And is it? Well, let's go back and check. What's 2 times pi on 2? It's pi. What's the sign of pi? If you do it on your calculator or look up anywhere, it's 0. So the left-hand side is 0. What's the cos of pi on 2? Also 0. So pi on 2 does satisfy that equation, so it's a solution. All right, so we can check that. Check, that works. And our last solution, whoops, it won't be between 0 here, it's between pi on 2 and pi. So i.e., that's a tick there, that's a third quadrant solution. There's an angle between pi on 2 and pi, and so there's an angle between pi on 2 and pi, which is in here. Whoops, that must be second quadrant, get it right. It's a second quadrant solution. In there. Slide it up. I was trying to keep that on the page. But there you go. Look, I finished the lot.
Is there an even number of radians between x1, x2 and x3?
Are these solutions symmetric?
Yeah.
Yes. That's not a very informative answer, but you'll see why at the end. Okay? I'll tell you how I know that. But that's a good observation. All right, let's build up. So I'm going to finish off by solving that equation. Okay? But I'm going to build up to it. So let's do the simpler one. So here, I want to solve tan x is equal to the square root of 3, and x I'm going to restrict to be in the first 4 quadrants, so just from between 0 and 2 pi. So, let's sit in here. Well, actually, we can do a few things. Let's start off. So I'll just say, as an aside, sitting here, if I were to draw the graph of tan x between, and let me now, that's x, this is y, the graph of tan x goes like this. So 0, pi on 2, pi, 3 pi on 2, and 2 pi. So that's the graph of y is equal to tan x. The graph of y is equal to the square root of 3. The square root of 3 is up here somewhere. Across it goes. And so I can see that there will be 2 solutions. One there and one there. So there are 2 solutions. One between 0 and pi on 2. So a first quadrant solution. And the other one is between pi and 3 pi on 2. And so third quadrant. I'll say 2 solutions. Nah. I'll just say first quadrant and third quadrant is the easiest way to put it. I could have also thought to myself this. I could have said, look, remember we had this all ASTC mnemonic. It says, in the first quadrant, all the trig ratios are positive. In the second one, sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, cosine is positive. So, tan x is going to be a positive number, can only be a positive number in the first quadrant and the third quadrant. So tan is positive, tan x is positive in first quadrant or third quadrant. So either way, I'm going to get a solution in the first quadrant or the third quadrant, but not in the second or not in the third, not in the fourth, I should say. So I'm going to get, when I restrict myself to this domain between 0 and 2 pi, I'm going to get two solutions. Now, you could say, look, x is equal to tan inverse root 3, and whip out your calculator and get an answer. That would give you an approximation. In this case, we immediately think of our special triangles, don't we? That's what first thing that came to your mind. And in our special triangles, we had one here where the angles are pi on 3 and pi on 6, and the side lengths were 1, 2, root 3. And so, what angle has as its tan root 3? This angle here, pi on 3. Root 3 divided by 1. So I can say, in the first quadrant, x is in fact pi on 3. That's from my special triangle. And I guess if you got your calculator out and actually did tan square root of 3, you'd get an approximation to pi on 3. Sorry? Your calculator is in radians, is it not? It should be. Right? Because that's what pi on 3 is in degrees. Okay, so that will be the most common mistake people will make. Get your calculator into radians when we're doing these things. I mean, 60 degrees is the correct answer if you want the answer in degrees. I can't imagine myself in the multiple choice thing saying, give me the answer and then give me your pi on 3 and 60. All right? Because I've already asked the question, can you convert pi on 3 to 60 degrees? So I won't be checking that again twice. Okay, but the next thing is we need the third quadrant answer now. In the third quadrant, what's the angle that's going to work in the third quadrant? And then we have to hark back to what we did on Tuesday. So on Tuesday we did something like this. I said to you, if here's my unit circle, and you have to use your imagination to say that's a circle, but anyway, there's my unit circle. And in the first quadrant, pi on 3. There was pi on 3 sitting nicely there. And there was my right angle triangle sitting nicely. Now, I can relate that triangle to this triangle sitting here, where that is pi on 3. So this point here and that point there, the side lengths will be the same because these two triangles are congruent. So the tan of this angle sitting here will be the same as the tan of that angle sitting there. This angle, I know that's pi on 3, but in terms of angles, in terms of the third quadrant, it's all of that around there. So my third quadrant answer is pi plus pi on 3. So in the third quadrant answer, x is equal to pi plus pi on 3, which will be 4 pi on 3. Alternatively, you might have liked to have thought to yourself, look, I'm working here with the tan graph. The tan graph is periodic with period pi. And so it repeats itself every pi units. And so I can say to myself up here, this distance must be pi, from there to there. And so if that answer is pi on 3, this answer must be pi plus pi on 3. So whichever way you like to think of it, the answer is 4 pi on 3. Personally, I actually always work in terms of the unit circle, but that's not necessarily the best way. It's just the way I've got used to doing it. You can choose. And in fact, I think in schools they teach you always work from the horizontal or something like that. I think is the mantra that they say there. But I just draw the picture and say, okay, I've got to add pi to it. So we have our two answers. So the answers are pi on 3 and 4 pi on 3. Okay, that was fun. Let's do another one. So I'm trying to solve, in this case, again, the domain is going to be restricted to 0 to 2 pi, and I want to solve the equation 2 sine x plus 1 is equal to 0. So I can get this far fairly quickly. If 2 sine x plus 1 is 0, sine x has to be minus a half. So I've just done some simple algebra to make sine x the subject. So sine x has to be negative in here. And you can see A, S, T, C. Where is sine negative? It'll be negative in the third quadrant and in the fourth quadrant. So there will be potentially here two answers. A third quadrant and fourth quadrant answer. Alternatively, if that doesn't appeal to you, you might have said to yourself, I know what the graph of sine x looks like. It comes up like that. That's 1 down to minus 1, pi, what do we got here? Pi on 2, 3 pi on 2 and 2 pi. Sine, so that's the graph of y is equal to sine x. I now draw the graph of y is equal to minus a half, and that goes through here like that. So there's the graph of y is equal to minus a half. And we can see two answers, one sitting there and one sitting there. So there's one answer between pi and 3 pi on 2, which is my third quadrant answer. And there is one answer between 3 pi on 2 and 2 pi, which is my fourth quadrant answer. So I can say either of those two things will tell you that you're going to get two answers, one in the third quadrant and one in the fourth quadrant. Now for the minute, in here, look, I could go x is equal to sine inverse minus a half, but the half here is a real giveaway. And once again, let's go with our special triangle sitting in here. Pi on 3, pi on 6, 1, 2, root 3. And I can see that the sine of pi on 6 is a half. Pi on 6, of course, is a first quadrant answer. So note, sine of pi on 6 is equal to plus a half. So now I've got enough information in which to solve this. So let's go now and try and find our third quadrant answer. So I can go in the third quadrant. In the third quadrant. And I'll go over here and use my unit circle. So I've said here the sine of pi on 6. So pi on 6 is fairly small, so it's about like that. So there's pi on 6 sitting in there. And I want and there's the right angle triangle that I work with. I want the third quadrant equivalent of that triangle. And that will come down here like this. And so that angle in there is also pi on 6. And so the angle, the third quadrant angle that we want, is the one that starts here and goes all the way around. So that should be x dash, y dash, 1, 1, minus 1, minus 1. So I can see in the third quadrant, x will be pi plus pi on 6. Pi plus pi on 6. And so I will get 7 pi on 6. That will be my third quadrant answer. That's that one sitting there. Let's do the same now for the fourth quadrant. So in the fourth quadrant, now what triangle matches this one here, has the pi on 6 in the fourth quadrant? It'll be the one that comes down here. It's this one. That's a right angle. That angle is also pi on 6. So this is my fourth quadrant equivalent triangle. And you can see the angle now for that one is, if I can go right round, is this one right round here to there. And so that angle is 2 pi minus pi on 6. So in the fourth quadrant, the angle is 2 pi minus pi on 6, and so that will be 11 pi on 6. And Nathan, to answer your questions about the symmetries, you can see this one here, I've got to go pi on 6 past pi. This one I've got pi on 6 from 2 pi. And so therefore they're going to be equally spaced from those intercepts. Okay? That's where the symmetry comes from. So for me, in these ones, to work out the actual angle, I have a look at where the associated triangle is, and hence can see, okay, whether I subtract from 2 pi, add on from pi, or so forth. Let's do one more of those, and it's the one we started with. So let's now try and solve sine 2x is equal to cos x. And we'll only go between 0 and pi. Okay. So in this one, the only way we can make progress algebraically is to actually know some of the trig identities. And so in here, I'd imagine that if I was getting you to solve this sort of thing, I'd have to tell you which trig identity to use, I would imagine. And the one that is useful to us here is whoops, I'll go this way, is 2 sine x cos x. So one of the trig identities that we can derive is that sine of 2x is the same as 2 times sine x times cos x. I don't know if you knew that off by heart, but anyway, there it is, I've given it to you. And so what I can now do is on the left-hand side I can replace sine 2x by this. So I can say, therefore the equation becomes 2 sine x cos x is equal to cos x. Now I've got cos x on both sides, so this obvious thing to do is divide both sides by cos x. But I'm only allowed to do that if cos x is not 0. So I can say if cos x is not 0, then this equation becomes 2 sine x is equal to 1. And hence sine x is equal to 1/2. And so now we're in a similar boat to what we were over here. But let me go through it, even though we're in a similar boat, I'll go through it again. So sine x is 1/2. If I were to draw my sine graph, I can, and then draw my line y is equal to 1/2. So y is equal to 1/2, y is equal to sine x. So that's pi on 2 and that is pi. I can see that there are two solutions, one there and one there. I've got two solutions here. So there's a first quadrant solution and a second quadrant solution. So sine x equal to 1/2 is going to have two solutions, one in the first quadrant and one in the second quadrant. And I guess I did that by looking at the graph. You could have also said all stations to Cardiff, and sine is positive in the first quadrant and in the second quadrant, so therefore there's going to be a first quadrant solution and a second quadrant solution. Either way will do just fine. So we've concluded that there are two solutions. In this case, because this number here happens to be 1/2, we would suspect that our triangle over here, and I'll draw it again just so as we've got a complete thing. So I can say in the first quadrant, I can use this triangle again. So you can see I've used it a fair bit. 1, 2, square root of 3, pi on 6, pi on 3. So I can see that the sine of pi on 6 is 1/2. So I can see that x is going to be pi on 6. Let's do the second quadrant solution. You can always check this answer too, by the way. You can go back up here and say, well, what's sine 2x? Well, sine of 2 pi on 6 is pi on 3. So is the sine of pi on 3 the same as cos pi on 6? And it turns out they do. Okay, so you can always check that your answer is right. But let's now go on and do the second quadrant. So in the second quadrant, and again I'll do it via the unit circle. So let me call that x dash and y dash, and it's the unit circle. So here's my first quadrant triangle. That angle in there is pi on 6. So I want a triangle in the second quadrant equivalent to that. And so if I come across, here is the triangle that's congruent to that. That angle there is pi on 6. And so the angle, the second quadrant angle, is this one, from the positive x-axis around to there. And you can see that that angle will be pi minus pi on 6. And so our second quadrant angle here is x is equal to pi minus pi on 6. So that's 6 pi on 6, and so that ends up being 5 pi on 6. And so we found two answers. We found two answers. There's one little thing that we have to go back and check. Alright, so we've got those two answers. I need to slide back up to here. And remember I said to you, look, if cos x is not equal to 0, I can do this. But what happens if cos x is 0? So I need to check, is cos x equal to 0 a solution to this? If it is, there's an answer. If it's not, great, don't worry about it. But if I put cos x equal to 0, I have 0 on the left-hand side, I have 0 on the right-hand side. So cos x being equal to 0 is in fact a solution in this case. And so when I did that, I actually excluded that one solution. So I need to go back. I said, finally, check if cos x equals to 0 is a solution. In this case, it is. And so I get a third answer. It is. And so I can say for x between 0 and pi, cos x is equal to 0 when x is equal to pi on 2. And so I have three solutions. So my solutions are x is equal to pi on 6, pi on 2, and 5 pi on 6. And probably got it on the back of that page, have I? No. And so way back, I'll need to put this over the other side so the people at home can see it. So sitting here, that solution, x1, is pi on 6. There's my pi on 2 solution. This one here was 5 pi on 6. And so we've actually worked out all three solutions, which is really good.